Next up on the stage is Dylan Calhoun in the Cancer Bio program in Dr. Garcia Bermudez Laboratory, presenting Fighting Fire with Lipoproteins, Antioxidant Defense in Cancer.
When I was a kid, my dad taught me the basic lesson of fire safety, given that he's a firefighter himself, to always know where my fire extinguisher was. I never thought this lesson would come back to inform my work as a cancer biologist, but it turns out that inside our bodies, our cells are fighting their own unique kinds of fires every day. You see, as our cells burn fuel to make energy, this biochemical reaction produces tiny sparks or flames inside of cells called reactive oxygen species, or ROS, that serve to cause damage inside of those same cells. If these flames or sparks go uncontained, that damage will spread in an uncontrolled chain reaction and lead to a dangerous cell state known as oxidative stress. Normally, though, healthy cells are able to avoid this outcome by using antioxidants, or natural fire extinguishers that work to stop these flames before they spread. Cancer cells, however, live under a constant state of oxidative stress, particularly as they spread through our body during metastasis or face treatments like radiation and immunotherapy. And when the flames inside of these cells become too intense, cancer cells are known to undergo a unique and iron-dependent form of cell death called ferroptosis, where the cell's membranes are oxidized uncontrollably. Essentially, the cell burns from the inside out. My thesis research set out to ask and answer a simple question. If cancer cells live under constant fire, how are they able to survive? We made the surprising discovery that tumor cells are able to survive because they don't fight the flames on their own. Instead, they call for backup. As oxidative stress builds up, tumors begin taking up lipoproteins from the bloodstream. Yes, lipoproteins like LDL and HDL, the same particles that we've traditionally known to transport cholesterol throughout our bodies. But these particles don't just carry cholesterol, they also carry vitamin E, nature's most effective antioxidant. In this way, you can think of lipoproteins as fire trucks that are delivering vitamin E fire extinguishers straight to the tumor. And by taking up these antioxidants, tumors are able to build a biochemical fire-resistant shield that protects their membranes from burning. In doing so, they're able to survive this incredibly dangerous environment that they live in. And in particular, when we deplete lipoproteins of vitamin E or block the ability of tumor cells to take up these lipoproteins altogether, this protection is lost and the shield collapses. Cells that once seemed highly fireproof become highly flammable. These findings have important implications for cancer biology, suggesting that the levels of lipoproteins might influence how tumors grow or respond to treatment. My dad always said that the best firefighting isn't about putting out the flames, it's about understanding how fires start, and I hope that this knowledge will help us extinguish cancer for good.